Okay, in this video I want to have a look at sketching the graph of the derivative. So if we're given a function and we can see what its graph looks like, to be able to then graph the derivative. Now remember, our derivative function is all about our gradient function. We're looking at what the gradient is doing in that function. So when we look at this function, we can see that our line is heading upwards, so our gradient is positive. It gets to a point here and then it becomes negative as the line comes down. So what we've got is this changeover point, which we call a stationary point, and that's where it stops being negative and stops being positive and starts being negative. So what we'll do is we'll put this corresponding one, so that gradient is 0, in the same spot over here. So if this was at 1, then we would have our point at 1 here where we can see that it's cutting through the axis. We also know that when we have a quadratic, its corresponding derivative function graph will be linear. So we now have a straight line that we know is positive. When it gets to that 1, it becomes negative. So we can draw a line in there. Obviously we don't have exact values because we don't have a function here, and all we know is this value here where it has its turning point or its stationary point. So that's always the bit that we look for first, and then we draw in what else we know. Now in this next one we've got a linear function. Now we know that in a linear function the gradient is the same throughout the whole function. Now we have no values on here, so all we know about this is that it's negative because our line is going down as we move from left to right. So what we can do is put a horizontal line, make sure it's in the negatives, to show that it has a negative gradient that is constant for the entire time. Then we have a cubic here. So remembering our differentiation rules, we know that the cubic is going to become a quadratic. So we're looking at, like we did up here, these stationary points. So we've got a point here, so we might call that -1, and we might call that 1 there. So we've got our -1 and 1. We know are our turning points or our stationary points there. So that's where we're changing from positive, negative, or negative, positive. So here we've got a negative, and then it's becoming positive, and then it's becoming negative again. So we've got our line needs to be under the x-axis, so in the negatives. It then becomes positive, and then it comes back down and becomes negative there. So we've got our quadratic shape of our function. So always remembering our basic rules: linear becomes constant, quadratic becomes a linear, and cubic becomes quadratic, and looking at those features like where is the stationary point or turning point, putting them over there on our derivative in the same position, and then looking at what is happening to the gradient. So we've got a positive gradient and then a negative gradient, so we need our line to be above the x-axis, then below the x-axis. So in our original function, we're looking at when we're talking about our x and y values, but when we get over here, we're talking about is the gradient positive or negative. Hopefully that helps you with your graphing of functions and their derivatives.